Good morning, guys. All right, so hopefully you guys all have your scratch paper and you are all good to go for your notes. So today we are going to be learning about something very exciting called the law of signs. Those are supposed to be exclamation points. This is me failing without a stylus. All right, so the law of signs, that's what we're learning about today. And the most important thing that you guys need to know for law of signs is that we have no more right triangles. All right, I want you guys to all turn to your neighbors and say no more right triangles. All right, good. So no more right triangles, which means no more SOHCAHTOA. All right, turn to your partner, say no more SOHCAHTOA. All right, I hope you guys all did that. Okay, so we can't have SOHCAHTOA because if there's not right triangles, there's no hypotenuse. There's no opposite. There's no adjacent. So there's none of that left anymore. So we can't use SOHCAHTOA, so we have to have new rules. All right? So that rule for today is called the law of signs. So that's what we're going to be learning about today. And so the law of signs is very useful. But one thing that you guys need to know is that the law of signs does not always work. All right? The law of signs does not always work, and we'll talk a lot more about that next week, all right? And the reason it does not always work, we'll talk more about the reasoning next week, but if you guys remember back in geometry, you might have learned that there is no side-side angle theorem, okay? If you guys remember learning about your congruence theorems with triangles, there's no side-side angle theorem. And so because of that, okay, some of the triangles we're going to learn about, if we have triangles that have a side-side angle situation, all right, that means that we cannot use law of signs. And so that's going to be a problem. That will cause an issue. So there's something called the ambiguous case, and I'm going to show you guys kind of how that works. We're not going to delve super deep into it, but we will kind of see why it doesn't always work. And there is something called law of cosines, and law of cosines works every single time, all the time, without fail. So you might be like, well, why don't we always use law of cosines? Well, what you're going to find out next week is that law of cosines is really complicated and ugly, and it has a lot of steps. And law of signs, you will see today, is very easy. So we use law of signs when we can because it's so simple. So, but it is, like I said, it's really important for you to know you cannot use law of signs all the time. Don't get totally hooked on it because it doesn't work all the time. Now, every example we're going to do today, every problem on your homework, it's cool. Okay, so not a huge deal, not a problem. You can use it on everything that I'm going to give you today. I'm not going to give you anything with the ambiguous case today. Everything today is cool for law of signs. So just know, all right, that we can't use it all the time. So law of signs, here is what I want you guys to write out in your notes. Now, we're going to write it out using the letters A, B, and C, but hopefully you guys can figure out that you can always use other letters other than A, B, and C. So the way that it's going to be written out is going to be sine of big A over little a equals sine of big B over little b equals sine of big C over little c. And you might be like, well, hey, what's up? Why are there like two different equal signs? Yeah, that's pretty weird. That's pretty funky. But we only ever use two pieces of this formula at once. We don't ever use all three. You just pick two. You're like, oh, I want to use this one and this one, or I want to use this one and this one. So you just pick two of them, and that's what you use. So, but here, this talks about all three different sides of your triangle and all three different angles. Now, hopefully you guys can remember from geometry that the big letters always refer to angles, and the little ones always refer to sides. So that's what you guys are going to be doing with those. So here, as long as you can keep track of, one thing that's really important and that should be really obvious to note is that the letters always match up. A goes with A, B goes with B, and so on. Or whatever different letters we're using for whatever triangle we have. So you just have to match them up. And other than that, it's basically kind of like, hopefully you guys saw in the bell work today, it's basically just like a proportion. Okay, you're just going to go through and solve those. So this is your formula. This is what we're going to use. We're going to pick the two pieces that we want. Now, these are our examples. Now, I'm actually going to pull an example that looks all clean and neat that I took from my nice little program that I have. It's not going to use the letters A, B, and C, and I'm going to show you how to adjust for that. It's not a big deal. But this is what the formula usually looks like, so that's why I'm showing it to you guys with these letters here. So I'm going to go ahead and move this out of the way here, and I'm going to grab one of these examples and show it to you. So let me see if I can zoom. Really? It's not going to let me do this? That's so convenient. All right. So I'm trying to make this bigger, and it's not letting me. That's fantastic. All right. So I'm going to see if I can add it again. So one thing that you guys are going to notice while I'm pulling this up is that on some of these, here, there we go. That's the one I wanted. You get out of the way. That's annoying. So you'll notice on this one, a couple of things that I want to point out here is that here they label this kind of funky. They ask you to find PQ. I feel like it's annoying to use all these letters. Here, what side length do you guys think we're going to call PQ? Well, we're going to call this little r, all right, because it's across from angle R. So I would actually cross this off and say, find little r. This is little r. That's what we're trying to find. So here we need to go through and decide, how are we going to find little r? Now, if you guys were really like stressed out by this, you could cross these off and put A's, B's, and C's. I think you guys can figure out what this is going to look like. So for this version of the formula, if we really wanted to, we could rewrite this as sine of big P over little p equals sine of big Q over little q equals sine of big R over little r. So this is the same as like the ABC business, all right? And we're going to go through and use whichever pieces of the formula are convenient for us. Now, one thing you guys need to know is that you're always going to need to have two matching pairs. A pair of angles, or a pair of side and angle and a pair of side and angle that match up. So I'm going to look and say, what do I have? All right? So I know here that I was given this side and that I'm looking for this side. Now, this is actually kind of a sneaky example for us to start with, because you guys can see this side length that we don't have his matching angle. But you guys are smart enough to look at this and say, well, yeah, we do. We do have that missing side. They didn't give it to us, but we can certainly figure it out. So we can grab our calculators and figure out, when we subtract my other two angles, that this missing angle right here is actually going to be 50. All right, so that's the one that we're going to use right here. Okay, we can figure this out, and we know that this is 50. So this is one of my matching sides and angles. That's one thing that I can use here. So I know that I'm going to want to use this piece of the formula because I have big P and little p. So do you guys see that this side length here, I could call that little p. So I have big P and little p here and here. And then they're asking me to solve for little r. So I'm going to want to use big R and little r. So I don't really need to use this guy right here. I can just kind of ignore him. All right. If it was me, I'd maybe scroll that out. I don't know if that's useful for you guys. So the two pieces of my formula that I'm going to use is I'm going to use this guy and this guy. So I'm going to go ahead and set this up. So really what it's going to look like is it's going to look like sine of big P over little p equals sine of big R over little r. All right, so that's kind of how this is going to look. I'm only using two pieces at a time. All right, so I'm going to take this guy here. Oh, it's going to connect those. Okay, we'll just put him over here. Can you guys still see that? Hopefully you can. So I'm going to start plugging stuff in here. So the way that I'm going to plug this in is I'm going to have sine of 50 over little p, which is 34, equals sine of big P, or big R, which is 82, over little r. All right. So we have that all set up. So I'm going to move this up here. I'm going to move this guy out of the way for sure. There we go. All right. So here's what we're kind of looking at. So I have this set up. And so now I can treat this kind of like the bell work. I'm going to go ahead and cross multiply here, and I'm going to get r times sine of 50 equals 34 times sine of 82. So a couple of things to note is that this is like a variable. This is the variable that I'm solving for. Sine of 50, that's just a number. I can get it on my calculator. Now, I could get the decimal now, but I don't want you guys to round until the end. So here, remember, the thing that I'm trying to solve for is the r, so the thing that I'm trying to get rid of here is the sine of 50. So I'm going to go ahead and divide both sides by sine of 50. Now, I hope that you guys are all smart enough to know here, okay, these are going to cancel, and I'm left with r equals all of this business here. Now, here's what you guys are going to have to be careful about. I hope you guys are all smart enough to know I cannot cancel the signs. That is not a thing I can do. That's like canceling a square root. That's bogus. That's an operation. But I can put this all in my calculator all at once as long as I am savvy about my parentheses. I'd have to put parentheses here around the 34 sine, and then it's going to put parentheses here around the 82. So I'm going to have to close both of those parentheses here after the 82, and then I can divide by sine 50. If you don't think you can do it all at once, do 34 times the sine of 82, and then hit enter, and then divide by sine of 50. So I'm going to give you guys all a second to do that in your calculator, and I'm going to do it in my calculator. Now remember, guys, that you need to be in degree mode here. We still haven't switched it, so that should not be a big issue. So when I put that in my calculator, I get about 43.95. So if I round that to the nearest tenth, that gives me 44.0. So I get 44.0. And the units that they gave me for these side lengths were centimeters. So let's talk about this. So that gives me 44.0 centimeters. So if I think about that, let's think about that and see if that makes sense. So if r is going to be 44, r is across from 82, so it should be bigger than the 34 that was across from the 50. So that answer makes sense. That checks out, and I am super happy with this answer. All right? So that is a pretty easy one. That's not really a huge deal. It's pretty easy to solve for the side lengths. All right? So if you guys have any issues or any questions, you can help each other out. So that's what we do when we're solving for side lengths. All right? Now I'm going to go ahead and show you guys what's going to happen when we solve for angles. Angles get real, they're really not that hard, but they get a little bit different. So I'm just going to move everything out of the way. And it didn't let me load a picture last time, so I'm just going to load my picture on my own. So here's what we're going to do. When it gives us an angle to solve for, so something that looks like this. Now here we've got some other weirdo letters. So they want us here to solve for this angle P. Now remember here, guys, okay, the letters that I have here are H, K, and P. So the version of law of sines that I would use might look something like sine of big H over little h equals sine of big K, not sync, over little k, equals sine of big P over little p. So I'm going to look at my picture and I'm going to see what I have. Now I can see already that I have here both of these. I have big K, and this guy over here is going to be little k. That looks like a big K with my cursor. So I have big K and little k. So I know that I'm going to want to use this piece of the formula. Now they want me to solve for angle P, so I know that I'm going to want to use this guy right here, and thankfully they gave me the 11 centimeters. So the other piece of my formula that I want to use is the version with the P. So that H, that's not really useful. I don't really need him. I'm just going to use these two pieces. So I'm going to go ahead and set this up and plug it in. So I'm going to have sine of angle K, which is 88, over little k, which is 27. And that's going to equal sine of big P, which we don't know. That's what we're solving for, over little p, which is 11. All right? Now, at this point, we have a couple of different choices. I could go ahead and cross multiply. Now, you guys all, what you guys learn in middle school, you guys are really cross multiply happy, and you guys love cross multiplying. So you could cross multiply. But another thing you guys could think about here is, oh, that's going to attach everything. That's delightful. All right, so one thing that you guys know is we're trying to solve here for this guy. So really, I don't need to move the 27 over here with this guy. I can just get rid of this 11. If you really want to cross multiply, you could do that, but you're just going to have to end up moving the 27 back over here later. So I would just leave all of this junk over here and just get rid of the 11. So instead, I would just go ahead here, and I'm going to move this over a little bit. I would just go ahead here and multiply both sides times 11 so that these two cancel, and I'm left with this business over here. All right? Now, here's where this is going to get kind of dicey, okay? I'm just going to move this up here so we can see it a little better, all right? So here's where this gets a little dicey. Now, I'm going to, here, if we take a look at this, I hope you guys don't mind. I'm going to switch the sides just so we can have a little more space to work. So we have sine of big P equals 11, sine of 88 over 27. So that's kind of where we're at with this. And if you guys remember here, we're trying to solve for big P. Now, I could put this in my calculator right now, get a decimal, but I'm going to have to round it. So I'd rather just leave it the way it is. So what I'm going to do now, hopefully you guys have some sort of an idea, okay? I'm going to move that guy off to the side just for now, okay? So there's my picture. I'm going to move him off to the side. If I'm going to solve for this, if I want to get that P by itself, hopefully you guys kind of know. I would ask you to do this in class to talk about it, but since I'm not there, I'll just go ahead and tell you to get that P by itself. If I want to move, get rid of the sign, the way that I'm going to undo that is with inverse sine. So I'm going to take the inverse sine of both sides so that I can get rid of the sign that's on the left there. So I'm going to have the inverse sine of all this junky junk over here. All right. Now, you guys are going to have to be real calculator savvy to put all this in all at once and just be smart about your parentheses. But I have all the confidence in the world that you guys can do that. So I'm going to give you guys a second right now to put this in your calculator. Now, keep in mind it should be an angle, should be, you know, fit into the triangle. So let's go ahead and do this. So we're going to go ahead and put in our inverse sine. And you guys are going to have to make sure to know when to close your parentheses. All right, and when I am doing that, I get the measure of angle P equals 24.026. So if I round that to the nearest tenth, that's going to be 24.0 degrees. Now I'm going to check this guy out here. I know this is covering this up. But if I look at that for angle P, having that here, the 27 was across from the 88. So something across from something much smaller, it makes sense that that's a way smaller angle. All right. Oh, wow, really? This is so confusing. All right, so I'll move that out of the way. So that's how I get my answer here. So that's the only part that you guys have to be careful of is putting that in your calculator the correct way. So as long as you guys can handle that, it's no big deal. This is really super simple. No big deal. You guys can handle this. So you guys have a lot of work time to practice this. We'll dive a lot more deeper into this next week, but super simple. Have fun.